Hi, welcome back. In this lecture, what I want to do is I want to take another look at control systems which have a feedback. Remember, we call them closed loop control systems in the previous lectures. So I want to look at closed loop control systems and I want to compare it with open loop control systems which do not have a feedback. And uh, talk about what are the advantages of having feedback. So before we start that, let's just kind of define closed loop and open loop once again very clearly. So a closed loop system is a system where uh, you have feedback going on, right? So um, there is a process which is kind of giving you an output. This output is measured and compared with the desired output, and then the controller then controls the process so that this output matches up with the desired output. That's what we have been thinking about. This kind of a system is called a closed loop system. It's called closed loop because what you're doing is you're taking the output and then bringing it back, comparing it with the input, and then trying to control the process so that the output changes appropriately so that it becomes equal to the input. So it's a closed loop control system. Now, an open loop system is basically looks like this, right? There is you give an input, and maybe there is a disturbance, and the input and the disturbance give you an output. There is no way of feeding back information as to what output you're getting and changing it so that you get an appropriate output. The system is you have to design the system and then you give an input and you get an output. That's it. Uh, you can have a controller even in an open loop control system, so like shown here, but this also is an open loop control system because there is no feedback. A closed loop control system in variance with the open loop control system has feedback built into it. So it's not just that the input gives a particular output, but that the output is then measured using a sensor and compared with the input to see whether you have got the desired output or not. If you don't, then the error signal will drive the controller so that the process gives you the appropriate output. Now, of course, you have to remember that any sensor, there is a noise going to be associated with any sensor, right? And there is going to be a disturbance as well. And we have to deal with the effects of both the noise and the disturbance in the control system. However, in a closed loop control system, you have noise. In an open loop control system, you don't have noise. So that's an advantage of the open loop control system if you want to say it that way. Uh, so we're going to look at the open loop control system, which we saw here in this slide, and we are going to look at the closed loop control system here, and we're going to look at what is the advantage of adding this feedback loop. So before we get on to discussing that, let's try to find out the input output relationship of both the open loop and the closed loop control system. And in this case, the input, of course, the primary input is RS, but the disturbance and the noise signals are also input. So we will have to find out what the effects of the noise and the disturbance are on the output.